So before jumping into CPU scheduling, I would like to tell you few more terms regarding some time. Okay. So for a process, there are multiple kind of times associated. Okay. So in this video, before going to CPU scheduling, I will be elaborating those times. I mean those possible times which are associated with a particular process. Okay. But before that, I would like to give you a recap. So whatever we have seen so far. Fine. So first thing is context switch. Do you remember what context switch is? So if not, then let me give you a very high level brief. Okay. So context switch is, let's say there is a CPU. Okay, let me write it down. Let's say there is a CPU. There is process 1 was getting executed at CPU level. Okay. Somehow P2 has come. Okay. So when P2 has come, let's say for some reason it might be because of timeout or it might be because of low priority. Somehow your operating system may decide enough of P1. Okay, enough of P1. Now I will be pulling P1 out from CPU. Okay, and I will be assigning this P2 to CPU. Okay, so taking a process from a CPU and assigning one more process to a CPU is called context switch, and this context switch is a heavy work. So why context switch is a heavy operation? Context switch is a heavy operation because the moment a process is getting preempted, whatever the progress that process has already made, that has to be saved somewhere. And where this is saved? This is saved in the particular process control block, which is PCB. So everything, I mean every progress that process P1 has made so far, that has to be safely saved. Okay, then P2 has to be assigned. Why this progress has to be saved? Because once this P2 is over, let's say P1 is again getting chance into CPU. Now your CPU has to know from which instruction it is supposed to, it is supposed to execute the process 1, this process P1. Okay, so that is why whatever progress so far is made, that has to be saved somewhere. So that is why this context switch is a heavy operation. And which piece of software lifts this heavyweight context switch? So dispatcher comes and dispatcher takes care of this context switch. Okay, so preemption, next thing is preemption, that I have already told you. Preemption is, let's say one process is already getting executed at CPU. For some reason that process is getting pulled out of your CPU, so that is called preemption. Okay, then another thing, CPU versus IO bound. What is CPU bound process and what is IO bound process? So let me give you a small recap. So let's say there is a process. So whatever the entire lifetime of the process is, if most of the time is spent with CPU, that is called a CPU bound process. And if most of the time is spent using some IO operation, then that is called a IO bound process. Okay. So now let's get into these time things. So the first thing is arrival time. What is arrival time? Arrival time is a time when the process comes in the ready state. So the moment your operating system is creating a process out of a program and this process is successfully moved into ready state, so that time is called arrival time. So arrival time is not a duration. Arrival time is a point of time. Okay, at any particular time, let's say 10 p.m., 10 a.m., 11 a.m. So a point of time is arrival time. Okay. Now the next time is burst time. Okay. What is this burst time? Burst time we'll be seeing much more detail with examples. Okay. So as of now, burst time is the time when a process gets executed at CPU level. Okay. So we call it a CPU time as well. So let's say 10 minutes of CPU time or 5 minutes of CPU time. Okay. So that means that process will be staying with the CPU. Okay, for the 5 minutes or 10 minutes, whatever your CPU time is. All right. So then comes completion time. Completion time, again, this is not a duration. Oh, one more thing. This is a duration. Let me take it like this. This is a duration. Okay, this is not a duration. Okay, completion time. So completion is a time when a process finally gets terminated. Okay, and that means the process is successfully executed. Okay, so this is completion time. This is not a duration. This is a point of time. Let's say 10 a.m., 11 a.m., 12 a.m., something like this. Okay. So then comes this turnaround time. Okay. So what is turnaround time? So if I give you a mathematical formula, turnaround time is completion time minus arrival time. What does it mean? It means since the process has reached the ready state till the time when the process is successfully terminated. So this duration is called turnaround time. So in simple terms, turnaround time is a duration of time during which the process stays inside our system. Now, this wait time. What is a wait time? So, wait time is a duration of time. During that time, a particular process end up waiting for the CPU. Okay. So now we have seen so far wait time. Okay. So this arrival time is not a duration. This is a single point of time. This burst time. Okay. This burst time is a duration. Time duration. Okay. Completion time not a duration. What is completion time? A single point of time. Turnaround time. This is a duration. Okay. Let me write it like this. Turnaround time is a duration. Fine. Wait time. So the time, the duration in which your process waits for the CPU. So this is also what? Duration. Now let me go to the next time. So that is response time. So response time is, let's take an example. Let's say there is a CPU. Okay. At 6 a.m. you have got a process P1. Okay. Now got as in is in the ready state. Has reached the ready state. So what is the arrival time? So that is 6 a.m. Now let's say this process is scheduled to the CPU for the very first time at 7 a.m. Okay, till this 1 hour this process was not getting scheduled to the CPU. At 7 a.m. for the very first time, now the process is getting scheduled with the CPU. So the duration between the arrival time and the time when the process is getting scheduled for the first time, this duration is called response time. Okay, fine. So wait time, what is response time? Response time is the wait time before it goes in run state for first time. Okay, this is called response time. So already we have seen this thing. Completion time minus arrival time is something called turnaround time. Okay, and also I have told you turnaround time is the time duration. So in that duration, the process stays in the system from ready state to terminating state. Okay, so we can say this turnaround time is equal to wait time and the burst time. Okay, as of now consider there is no IO. So considering there is no IO, turnaround time is summation of wait time and burst time. Why so? Wait time is the time when your process is waiting for the CPU, and burst time is the time in that time your process is getting executed at CPU level. So if you combine these two, you will be getting the entire time duration during which your process was inside your system. Okay, so that is turnaround time, that is wait time, this is burst time. Okay, now so up to this example considers there was no IO. So if you see IO time, what is IO time? So IO time is a time duration. Okay, so IO time is a time duration during which a particular process waits for some IO operation to take place. Okay, now let's take this example. Okay, let's take this example. Let's say you have a CPU and you have a process which has arrived, your process has arrived at t equal to 1. Okay, and at t equal to 3 your process is getting CPU for the very first time. Okay, so this time duration is the response time. Let's say t equal to 3, t equal to 4, your process is with CPU. So these two time are burst time. Okay, let's assume at t equal to 5 your process got busy with some IO operation. Okay, so this is the IO time. All right, let's say at t equal to 6, at t equal to 6 your process is getting some CPU time. So again this is the CPU time, that is burst time. Let's say at let's make it wait time. Okay, let me make it a wait time. All right, so let's say at t equal to 7 and t equal to 8, these two time your process is not getting CPU and your process is waiting for the CPU. So it says this is the waiting time. Let's say at t equal to 9 and t equal to 10, again the process is getting the CPU resource. Okay, that means these 2 seconds will again be counted into the burst time. So at t equal to 10 your process is successfully completed. So that is why completion time is t equal to 10, something like this. All right, now this wait time. So wait time says is a CPU wait time. Okay, so let's remove this until and unless. Okay, so IO is mentioned, so that will be under IO time. All right, under IO time, if IO is mentioned, then it will be under IO time. Otherwise, wait time is for CPU wait time. All right.